Okay, we're going to take a look at hydrogen bonding, which is an important concept, an important type of intermolecular force. Okay, so hydrogen bonding occurs within compounds that have a hydrogen atom bonded to either a fluorine, an oxygen, or a nitrogen. So we've got an HF, HO, or HN bond, which is a highly polar bond. Okay, hydrogen bonding is a type of intermolecular force, okay, a force between different molecules. And here's an example. So let's look at, this is a hydrogen fluoride. Okay, so we've got H and F. Now, F is highly electronegative. What that means is that these electrons that are being shared by fluorine and hydrogen are strongly attracted to the fluorine. And if you think about hydrogen, what is hydrogen? Well, hydrogen consists of a single proton and a single electron. That electron now being shared with fluorine, and these shared electrons being pulled close to the fluorine and away from the hydrogen, basically leaving an exposed nucleus, which is obviously highly positive. And then fluorine, as well as having these electrons pulled closer to it, will have unbonded valence electrons around the outside as well. So what we end up with is a very negative end of the molecule on this end, and a very positive end on this end. And then between molecules, we get a strong, what we call a hydrogen bond between those positive and negative ends. And that's how hydrogen bonding works. So other examples are HO or HN, same thing. Fluorine is the most electronegative, nitrogen the least, but these are all considered to be highly electronegative elements. So it's due to the large electronegativity difference between hydrogen and one of those electronegative elements. And it's a strong intermolecular force, but it's still, even though it's a strong intermolecular force, we still consider that to be weak compared to the intramolecular covalent bonds. That's the covalent bonds within the molecule holding the atoms together. So here's a question: which functional groups will exhibit hydrogen bonding? Maybe pause the video and just think about that for a minute, and I'll tell you in a few seconds. Okay, alkanes do not, alkenes do not, alcohols do, because they have an OH, they have an O bonded to an H. Haloalkanes no, amines yes, they have a nitrogen bonded to a hydrogen. Carboxylic acids yes, they have an OH. Acid chlorides no, ketones no, aldehydes no, amides no, and esters no. So it's just alcohols, amines, and carboxylic acids that exhibit hydrogen bonding.